number of participants is increasing as I'm speaking. Just to make it clear, you are on the session on innovation strategy, and you would have a session on with the startup pitching. And so we're gonna have two sessions for this afternoon. The first one, the first hour, would be a panel discussing on the innovation strategy. And then the second one would be the pitch session with the startup. So this is our panel. We're very lucky to have you five that agree to join us. I really like the diversity on this panel, and I'm very happy that everybody could join. So we have Eva, that is the lead of Open Tech Lab at Elia Group. She's based out of Germany. We have Dean Cobson that joined from National Grid Partner. He's a UK business developer. And then we have Peter Sotoswam. I hope I'm not butchering his last name. From Vattenfall, and he's the head of innovation. Then we have Fernando Sandoval, manager at NL Innovation Hub Europe. And finally, Erika Velasquez, Digital Open Innovation Manager at ABP. And then to monitor the panel, Mark McGranagan, that I don't need to introduce to anybody, I think. Yeah, you can take it from here. I just want to remind everybody that there is a chat that is available on your bottom right. You should be able to see it, and you would be able to send any question that you have over there. We will monitoring closely, and then we're gonna have throughout the panel a Slido open. So we're gonna ask you some question, and we would love for you to answer it. You have two options to join it. One of them is a desktop option, so you'll have to go on slido.com and then enter this number, and you'll be able to log in and see those questions there. The second option is with your phone. You can scan this QR code and access it directly. And so like this, we will discuss those questions with the panelists, and we will see if everybody is thinking the same way or not. Mark, if you want to take it from here. Thank you.
That's great. Thanks, Annalise. And Annalise is one of actually our newest member of the technology innovation team at EPRI, who's joined to help coordinate our Incubate Energy Labs activities primarily that we run in the US, and she'll be talking about that in the second part of this today with a cohort of European utilities that are interested in participating in that. So we'll talk about that. My name's Mark McGranagan. I'm part of our technology innovation group as well, and helped start our EPRI Europe operation, which is a subsidiary of EPRI. For those of you that are not familiar, EPRI is a nonprofit research organization that primarily gets its funding from electric utilities around the world that collaborate on the research function. And one of the areas that we work with utilities on is innovation, is how they innovate, and organizational aspects of the innovation, and connecting to startup companies. So the way we thought we would organize things for this discussion today, the 2 hours that we have as part of a overall European Workshop Week, is that we take the first hour with some experts and chat about the innovation function at their companies, how they go about it, and especially the role of collaboration and what Annalise is calling open innovation here, a collaborative approach to innovation, how that works for them, and the importance of collaboration in their organization. And I thought what we would start, since we have such a great panel, is to give each one of our panelists 5 minutes or so to introduce yourself. I'm not going to go through the bio, so you can give us a brief background on yourself, and then maybe an introduction to your role within the organization, and some comments about how you connect to the startup community and innovation technologies and the role of collaboration in that function. So why don't we start with Eva Schramm from the ILIA Group. She's the lead of their Open Tech Labs and connecting to startup organizations and how those technologies could be used within the ILIA Group is a big part of her role. So Eva, maybe we'll start with you for a quick overview of from an ILIA perspective.
Sure. First of all, good afternoon to everyone. So happy to be here today. I think the weather is quite good here in Berlin. I hope it's the same for everyone else. By the way, I hope you can hear me well. Sometimes there are some trouble with the headset. If not, just let me know.
Sounds good.
Cool. So maybe just to give a first introduction about ILIA Group, just very quickly. I'm not sure everyone knows, but I think it's well deserved. So ILIA Group is a transmission system operator in 2 countries, actually. So we have our ILIA entity in Belgium and 50 Hertz in Germany. So where we're operating the high voltage grid in the eastern part of Germany. And if I would need to nail it down to 3 core activities, I would say it's balancing the electricity grid, facilitating the market, and operating the critical infrastructure. And of course, looking at the panel, we have a lot of similarities here. So we try to connect also the generation and the distribution, and we see a lot of changes, to be honest, already today and also in the future. If you look at consumers today becoming prosumers in the future and using, for instance, electric vehicles to contribute also to flexibility on the grid, then we see a lot of complexity upcoming, and there is also the big need for innovation and more specifically on open innovation. And I will just quickly also mention some examples how we deal with it in a second. But we also see that, and you all know that, we need to prepare for the large amount of renewable generation that will be integrated in our grid, not only onshore, but also offshore. So, and to make this actually happen and also the energy transition, we see that we constantly need to innovate. We see that we have to optimize our tools, our assets, our activities. And to accelerate actually innovation, we have put a multinational team in place so that operates in both entities. And one aspect is actually a strong business innovation focus. So we have people who have a direct link to all the core domains in our organization, and therefore they have a really strong network to all the business experts in our organization. And with that, they can ensure that there's a direct channel between everything that is coming from the outer world, whether it's a startup, whether it's an innovative solution, a new technology, whatever, finds directly its way to the business challenge, to the business experts. So that's our role, to also connect the dots from these 2 aspects. And it also helps them actually to accelerate and speed up the ambitious innovation roadmaps they have set together with the business for the next 2 to 3 years. And this is what we call a moonshot program. That's the first pillar of innovation in our organization, super close to the business environment and therefore the real challenges we see. And on the other hand, and that's a bit my focus and also the focus topic of today, we have the Open Tech Lab, which serves as a lab for the business innovation team, but also for the whole organization. And it is built to bring innovative partners, such as startups, but also technology trends, other types of partners, such as academia, to the whole organization. And how are we doing this? We create ecosystems. So setting up ecosystem, for instance, for asset management, working together with cross-industrial partners as well. But we are also doing scouting more specifically for startups. And I'm really looking forward to the pitch session today as well, to bring these new partnerships and their approaches, their mindsets to the organization. So that's a bit the scouting services, and this is also contributed by the Open Innovation Challenge we are launching every year, where we're looking also for a startup that could help us with a very specific business challenge. This goes along, and I think startups, for instance, are also very early signal for new technology trends, it goes along with this continuous watch. So everything we see out there that is a new technology trend that will hit us in the future, that will disrupt the way we are working, we put on our radar and we start to analyze also in details if we see a potential. We are typically not doing this alone, also with external collaborators. And yeah, with this, maybe to close the introduction, we want to also share all the knowledge from different partners, but also technologies we have analyzed with the whole organization, because we think it creates openness for technologies itself, openness for innovation, and also openness to from all our colleagues to work with new types of partners, such as startups together. So that's a bit creating the spinning wheel in our innovation organization, and with the main goal to put actually the outer world together with our core business, our business challenges, and create continuously disruption and innovation. So maybe I stop with that and hand over to you back, Mark.
That's great, Eva. That's a good start. I'll just one quick question. How important in the innovation process is collaboration, like let's say through ENSO-E and their innovation and R&D function?
It's huge, and it's nothing we try to overlap, but we try, of course, to complement. It's something that our company is so used to already since years. So we actually just dare to kind of attach also innovation activities around that. But it's a huge platform where we have a lot of exchange, and it helps also to get more from a centralized innovation with just a few people towards a decentralized innovation, which we would always try to target. So because we think there are many people in our organization who have the capabilities to do so. And if they are also linked to ENSO-E and to further networks and platforms, it will help them also to become more and more innovative themselves without actually needing us. So I think it's very helpful and very known in our organization.
That's great. That's great TSO perspective. And I think as a next step, we'll go to Peter Sotoswam for a DSO perspective. Peter's the head of innovation at Vattenfall Distribution in Sweden, and very active in many collaborative groups in Europe for many years. So I'm very pleased, Peter, for you joining us and giving us a DSO perspective on innovation challenges and your approach.
Thank you very much, Mark. Thank you for inviting me to this panel as well. I really look forward to this. I really look forward to hearing the pitches, and I'm actually looking forward to the whole week here with a lot of excellent setups from you at EPE. So thanks for that. Well, my name is Peter Sotoswam. I work for the Swedish distribution part of Vattenfall. Vattenfall is just shortly a utility operating in the northern part of Europe, Sweden, Finland, Denmark, Germany, Poland, Netherlands, and UK mainly. There are some other minor parts in but in the northern part of Europe. Active in all parts of the value chain here, and from a grid perspective, we at the moment only have a grid in Sweden, and it's mainly a rural grid as well, which affect, of course, the type of innovation that you enter into. I just to approach this with open innovation or innovation in general or collaboration, I'd like to make in the introduction, like put it a little on the context side here. We are in the middle of an energy transition here, which is over the last week, unfortunately, has been clear that we need to speed up quite significantly. It's a big change to the traditional way of doing, especially the electrical grid business. It's a big change, but it's not the only change that we have handled over the little more than 100 years that we have had electrical distribution. Change has been something that happened all along. The big difference here and the recent change happenings in the world is clear of that is time. It goes so much faster now than it has done before. Give some examples of this. Previously, building new city parks or blocks in a city were taking a decade or close to a decade. Now you can build that in just a couple of days from starting to finish. Looking specifically at solar panels, which at least in Sweden has a little easier to get permits. We are talking about months to actually from idea to deployment, and this is of course in a time scale that the distribution business has not been used to work before. We are also in the transition changing in the way that we have a new regulation. That's developing as we go, and really, if you ask somebody, nobody really had the answer, and that is in itself a challenge, and it in turn requires, of course, that you on the most important side, I think it's daring to embrace the change, that you actually dare to try new things, that you dare to make demonstration, real time, real life demonstration of both tools, methods, and technologies in your network in order to be able to meet this speed up of change. This is, of course, a very challenging setup, and how can you really approach that? I don't think there is a silver bullet here. It's more like a silver buckshot that you need. You need to deploy very many different types of solutions. There are things that I would say probably should be done in the traditional way. Maybe it should even be done internally. That could maybe even be some, even if there is very few such things that should be done in a competitive manner, innovation in a competitive manner. But those are really minor things. Most of it really requires that you collaborate in one way or another. I think there should be collaboration with authorities in certain parts. We tend to forget the authorities in this. They are very critical in moving forward, and especially we should speed up our way of moving forward. We should, of course, collaborate with different forms of suppliers. We should collaborate with universities and research institutes to bring their part in, and we should collaborate with startups. No part is really the only part. You can't bet and have your silver bullet, selecting one of them and say, okay, this is sufficient for us. You really need to look at this on a more buckshot perspective, that you need to do the right type of innovation with the right type of collaboration. And looking at it from a collaboration perspective, it's not an if we should collaborate. It's more, okay, how do you select which type of collaboration you should do in each specific case? Just to give an example of this from our from Vattenfall Distribution's perspective, we can see that we are doing when we are looking at, for instance, different type of diagnostics with electrical equippment. This is typically something that we feel that working with universities and research institutes is the most profiting way of doing, or the most promising way of working with that type of challenges. Working with, if we are looking at things that's close to the customer, you can take charging, for instance. How can you control charging? How can you plan ahead, both on the customer side and the network side for charging? This is typically something you should absolutely do together with the customers, together with other parts of the value chain, because it's here and now, and something that you can really try for real in a fairly large scale right from the start. So I hope through this introduction I've described our approach is really a variety of different solutions where I think startups certainly fulfill its part in this.
Great, and I appreciate the comment about all the different stakeholders that you need to collaborate with. I think that's right on target. And I'm going to move on to Fernando Sandoval with NL Innovation and NL's Innovation Hub in Europe. And I think Fernando can provide an interesting perspective from a very large organization that has innovation hubs around the world. And I wonder, if you feel more competitive around your innovation function with your own innovation hubs, or how important collaboration is with other organizations that are working in this space. Fernando?
Thank you, Mark, and thanks a lot for the invitation. Well, let me first point out that we have set up the innovation hubs to do collaboration with others. That's been the whole purpose. And let me explain it a little and go a little bit further on that. So we're NL. NL is a very large Italian multinational vertically integrated utility. We cover the whole value chain of electricity. More than 85 gigawatts of installed capacity, about 50 gigawatts of renewable power, more than 2 million kilometers of distribution grids under management, reaching 75 million customers. So we are talking about a huge company. We're present in more than 30 countries, in fact. We have been doing innovation for many years. In fact, open innovation, and we started working with entrepreneurs about 10 years ago. So we had our first program, and at the beginning it was more a social responsibility oriented program, let's say, but we discovered there was a huge opportunity for us regarding innovation, and we started developing what we call the entrepreneurship practice. About 5 years ago, we decided to open our first innovation hub in Israel. We had a clear understanding that it was a relevant ecosystem of innovation for us. We didn't have any operation there, so we needed to start from scratch. It was successful. Then we decided to open in Silicon Valley, second relevant innovation ecosystem for us. And then what we did was to put all these innovation entrepreneurship practices we had in different parts of the company under the Innovation Hub umbrella. And that's how we created the network of 9 innovation hubs we have right now around the world. It is not the only innovation structure we have. In fact, we are just one of what we call innovation enablers, innovation units within the company have to do innovation. So we are structured in global business lines. We have 5 main global business lines. Each of them has their own innovation structure. This innovation structure is in charge of identifying the needs and challenges of the business, finding or identifying the best source of solution, either internal or external, developing the solution and delivering the solution to the business. Then regarding innovation enablers, as we call them, we have a crowdsourcing platform where they can upload all the challenges they have. It is called openinnovability.com. I invite you to visit it. We have people working in innovation culture. We have people working in entrepreneurship. We have people working on how to share best practice, and we have the innovation hubs. As innovation hubs, our main responsibility is to do scouting of startups and innovative SMEs able to solve the challenges and needs identified by the innovation units of the business lines. And second responsibility we have that we think is very important is to position the value proposition we have for startups in the different ecosystems where we are present. The value proposition we have is of venture client. So it means that we want to do business with the startup. We do not invest in the startups. We don't have such a thing as a traditional corporate accelerator. What we want to be is a growth platform for the startup. We want to work with them in the best possible way. We typically start with a pilot or a POC so that we can test not only the solution, but how the startup integrates with our processes, with our teams, with our systems. We can also validate the business case behind the project. And if it is successful, we scale it up, which means the startup becomes a regular supplier of the group. That is the ultimate goal of the open innovation model we have with the startups. We want them to become suppliers of Enel and have Enel as a client of reference. In the last 5-6 years, we have worked with more than 460 startups, out of which about 120 have become suppliers of the group. It is not the only source of innovation we have. As Peter was mentioning before, we also work with universities, with research centers, with major vendors, and it is the innovation units within the business lines, the ones who decide how they want to do the innovation and who they want to work with. Once they decide they want to work with the startups, they activate us, they activate the innovation hubs, and we go ahead and look for the best possible solution by a startup they could work with.
That's cool. I got a quick question for you. Enel has I think in a very unique business venture in starting a company called Gridspertise, that where you're offering technology and services to other distribution companies. And I wonder how the innovation hubs, is there a flow of some of these relationships and technologies into agreements or ways that Gridspertise could then help market and commercialize those technologies, or is that not a connection that you make?
Yeah, just to give some context, indeed, Gridspertise is the, let's say, most recent venture of Enel. It was created by the infrastructure and networks area to put in value all the knowledge and all the technology developed by Enel in the last 20 years, starting with the smart meters, all the way down to smart grids, digital twin, and the great infrastructure of the future. So the idea is to be able to deliver all this technology and all this knowledge Enel has to other DSOs, so they can also bring that expertise, smart grid technology, into their own grids. We are in fact collaborating with them. It is done through the innovation unit of the grid of the infrastructure and networks area. Gridspertise is another business unit we work with, let's say. So we indeed collaborate with them, trying to bring new knowledge to Gridspertise. It is kind of a chain, is infrastructure and networks, our DSO, working with the startups, working with new technologies, developing solutions, and if these solutions are successful, seeing how Gridspertise could put that in value and bring together all that innovation to other DSOs.
That's perfect. Thanks. And very interesting scenario and structure that I think the whole industry is going to be watching. I'm going to jump ahead to Dean Copson, who's with the National Grid Partners, part of the National Grid organization. And it's a very interesting role and aspect of that some utilities in their corporate organizations have, actually looking for investment opportunities in technologies that work in the energy space. And I think that's an interesting perspective and how the role of collaboration fits at National Grid Partners. Dean?
Thank you, Mark. I was very interested listening to Fernando there, because there were so many synergies there, apart from obviously Fernando's is kind of falls short of the investment. So we're very, very similar in the way that we operate from listening to Fernando's kind of introduction there. But obviously we do then go on to invest in startups, which is probably the slight difference there. For those of you that don't know National Grid, we operate out of the UK and the Northeast US. So in the UK, we're the system operator, we're the TSO. We're also now in the distribution network with our recent acquisition of WPD. And we were the gas transmission lead in the UK as well, but we're actually in the process of selling that business, which I think you're probably all aware of. In the US, we are transmission, distribution, customer for both gas and electricity in New York and New England in the Northeast. We also have the non-regulated business, which has, I'd say, two primary focus area. One is interconnectors, so they're the connections from the UK to continental Europe and Scandinavia. So that's a big focus for our non-regulated business at the moment. And we also have
and Ireland and Ireland.
And Ireland, yes, thank you, Mark. And then the energy renewables business, which is obviously that's in the northeast of the US. So obviously a lot of wind farm development, offshore wind, etc., etc. So quite a large and diverse business across the whole energy sector and utilities sector. I work for National Grid Partners, as Mark just said. So we are the corporate venture capital and innovation arm of National Grid. So we were set up by the CEO, John Pettigrew. So John allocated a good chunk of shareholder money from National Grid shareholders for us to go out and engage with and invest in the startup ecosystem. So again, very similar to Fernando, that the core of our team is headquartered in Silicon Valley. We're led by Lisa Lambert, who was brought over from Intel Capital to lead this corporate venture capital fund. There are other elements to National Grid Partners. So corporate venture capital is one portion. There's also an innovation reporting arm. There's an innovation arm that specifically looks at new innovations and business model changes. And we also have an area of National Grid Partners that's focused purely on collaboration. So looking at developing innovation within the organization, but also engaging with the wider utilities industry. We have something called the Next Grid Alliance, which has a number of working groups in certain areas around things like transmission, around cyber. Really pleased to see Jason from TS Conductor on the call. Hi, Jason. TS Conductor are one of our portfolio companies, so obviously have to give a shout out to Jason for some of the fantastic companies we invest in. So yeah, we were created by John Pettigrew. As I say, it was shareholder money. We currently have, I believe, 37 startup investments, and we also invest in 3 other funds, which gives us that co-investment ability. So we're actually co-investing with 3 other funds based in the US, Israel, and the UK. So for various reasons, I won't take all the time going into that detail. We are by no means, and I think Fernando touched on this, we're by no means the only innovation function within National Grid. We are just one of a number. The business units have innovation teams. The business units themselves do innovation. Obviously, we work very closely with those parts of the organization. But ours is very much focused on bringing in that startup mindset, that entrepreneurial mindset into National Grid. That the startups that we invest in provide. So that's really what we're all about. I think, I think probably that's probably it at the moment. I mean, I work in the business development team, so our sole purpose is really to work closely with our business units to understand what their priorities and challenges are, and then we effectively match that to our investment strategy for startups. So there's a dual element to our investment strategy. There's the strategic. So we've got a mandate to at least have, I think, 75% of our investments should be strategic. And what we mean by that, it's core to our business. So we're not just investing in any startups. We're investing in startups that are very relevant to what our core businesses do, as you can probably tell with investments like TS Conductor. And then the other aspect of course, there is a financial aspect to it as well. So we've got a very experienced team of investors. A lot, as I said, followed Lisa from Intel Capital, so that, you know, because it's shareholder money, there is an element there of wanting to make money from our investments as well. But I guess more importantly, build our startups and support them in their growth, and then help them work with energy and utilities companies to grow their businesses.
A quick question for you, Dean,
Sure.
in terms
Sure.
of, I think the UK has I'd say kind of a unique structure from a government point of view in sponsoring innovation and collecting funds from the DSOs and the transmission organizations that then is available back to them to sponsor innovation projects. And I wonder, at National Grid Partners, is there a connection to innovation fund kinds of projects that you would be looking at to help startup companies get in line for things like that, and maybe especially as the UK is kind of just starting a UK innovation, you know, that links directly to startup companies and stuff. Is there a connection between National Grid Partners and those kind of government sponsored efforts in the innovation area?
Yeah, there is, Mark, and it's a great question. We obviously work very closely with our colleagues within the innovation functions within the business units. So I work very closely with the ET, the electricity transmission innovation team, and the gas transmission innovation team. Obviously, one of the interesting dynamics there, and maybe it's a topic to discuss, but obviously the focus of Ofgem generated innovation is obviously very much around innovating and generating that for the broader industry within the UK. Where that can be at odds, of course, sometimes with startups is obviously, you know, startups are very much about retaining their IP and building their business very quickly. So there's a point there where it becomes interesting. I think that the challenge there and the way we really get around that is just making sure that we're engaged at the right time. So timing is absolutely everything in terms of where a startup is on its growth trajectory, and then when the regulatory funding comes in, and you've really got to make sure that those two things meet at exactly the right point so that it benefits both. That's the real challenge, I'd say, Mark. But we work very, very closely with our colleagues in the innovation teams, because if you get that right, it's a hugely powerful vehicle to both innovate, of course, but obviously to help accelerate startups through that type of funding. It can be hugely beneficial. So that's what we really focus on, is that timing element.
Yeah, right on. Let's go on to our last panelist, and Erica Velasquez is the Digital Open Innovation Manager at ABB's electrification business. And I think it'd be very interesting to get a vendor perspective in the innovation space and how you connect to some of these open innovation activities that are going on in the utility sector and other collaboration opportunities that you guys take advantage of.
Yeah, thanks, Mark, for the intro. And I think from the vendor perspective, as you were saying, we also see many of these trends that the colleagues have mentioned, and that's also what's led us to reinvent and reimagine the way that we do innovation, though, at ABB. And I think many of these trends have been mentioned before, like the sectoral convergence. If we think about utility or power distribution industry, digitalization, energy transformation, the famous 3D or 4Ds, we see all of this converging at speed, really. And that has led us also to rethink how are we innovating. It cannot be just inside out. It also has to come from outside in, and we need to make those boundaries much more permeable and leverage the best out of that startup and scale-up community that it's really very vibrant. and where we can benefit certainly from speed in the market and better serving our customers by applying all of these new innovations to our areas of expertise. So as you know, the ABB group is formed by 4 different business areas, out of which electrification is, let's say, having the portfolio from substation to sockets to enable smart, safe, and sustainable electrifications. So our offering comprises not just hardware, as we are best known for, so anything from low, medium voltage, EV charging infrastructure, modular substations, distribution automation, power protection, and smart buildings. But we're also now building a digital offering on top of that. And here's where we see that really the differentiator is in digital. It become the key differentiator. And here what we have seen is that we can actually bring more value to our customers by leveraging those innovations from the startups and coming together to the market. So as others have mentioned, the answer to open innovation is multiple, and it's decentralized. I think this is also common with the other utilities that have been presenting here in ABB. So when we look at it from the different stages of innovation, we have different entry points, let's say, for the open innovation and collaboration models. So we have interactions with the startups from our R&D departments, and this is exploring actually at game-changing technology where the time to market, it's not there yet, but we want to, get our first exposure and experiences there. Then we look at it also at the scale-up stage, and we also look at it at the acquisition stage. So I think here what we mean is that we're open to working with the startups across all phases, whether that is a make, really, invest, buy, or borrow decision. And I think that's what we see, that the number of vehicles or tool sets that we have to engage with the startups has really, the options have really multiplied in the last few years. Where we are very mature, of course, is in our fully inorganic approach, let's say. So of course, mergers and acquisitions, venture capital investment are also where we are quite active in case we want to really take ownership into a technology that is already mature. And I would say traditionally that's where the startups know us for. Where we have ramped up the activity lately with the convergence of sectors, as I was mentioning before, it's in collaborative vehicles. So this means partnerships, commercial, go-to-market, co-marketing, and also similar to what Fernando drives at Denel, venture clienting. So basically, how can we leverage a mature solution from the startup and then co-create and apply it together to one of our existing technologies or solutions. So here we have been successfully running, sorry, for the 3rd year startup challenges, and it's also quite similar to what Eva is doing at Elia Group. We define a specific challenge that is addressing a gap or a need in our portfolio where we want to take a solution to market within the next 18 months, let's say. We put it out there and we, let's say, crowdsource the solution from some of the startups. We award them a paid proof of concept. And at the end of that collaboration, we expect to see a minimal viable product that then our operating units or our businesses take the ownership of, and they take the leap in a way and take it to the next level to commercialize it to our customers. We're doing these challenges in collaboration with Synerlip, which is our startup accelerator. And what we have seen here is they shift from working with the startups just to discover technology and at an early stage, let's say, to actually driving business value, not only for our customers, but also for us to help accelerate the delivery of our solution roadmap on one side, and on the other side to also bring differentiated solutions to our customers. So it is a very interesting collaborations. I think in these innovation units, we're being really orchestrators, let's say, between many different stakeholders internally So our different supporting functions, our different businesses where the innovation is being created on one side, and on the other side, the external innovation ecosystem as well, and also helping our colleagues better learn how our startups are expecting to collaborate with these, giants, if you will, or very large corporations. I think that's another big learning for me and for my colleagues as well. How can we work with these startups in partnership, right? Rather than in a very asymmetrical way. How can we best play ball in a way with them and help them preserve actually that agility and that way of innovating very close to the market and very close to the customers, that it's really helping them differentiate.
That's great. That's fantastic. Let me take just a slight diversion here and mention again that we have a Slido session open with 3 questions, actually 4 questions, 3 A and B is on there, and everyone attending can access that Slido. Annalise will put the link in the chat as well, and we can revisit the results of this little survey. We can revisit it between this panel session and the pitch sessions, and then we can revisit it again at the very end of the pitch sessions, if that makes sense to you, Annalise, and see what your feedback looks like. But these questions relate to your different approaches to open innovation, your approach to collaboration, and like Peter mentioned, the different stakeholders involved in the collaboration, and then the benefits and barriers to open collaboration. And we've been talking a lot about that already in this initial session. In the little bit of time that we have available, I think I will go to a topic around enabling new technologies and startups through open source versus approaches to interoperability. I'm seeing more and more utilities wanting to make sure, even when they work with the large vendors like ABB or vendors of distribution management systems or energy management systems, they want to make sure that the systems are open to bringing in new functions from startup companies. And I think that applies to technologies across the board. How we kind of continue to take advantage of the strength and the commercial support of our vendors, but creating an open platform that startups can plug into. And maybe going back to Peter and Eva to start that discussion with a quick thoughts.
I think it's something, maybe if I start, Peter, sorry for hijacking.
Go ahead, Eva, please.
For us, or what I see in our company, is that open source is becoming more and more attractive, actually. So I think we are not there yet to have a full open platform that is kind of really can be leveraged on different types of projects. I think we are kind of looking for a specific project where it makes sense, where we are also looking in really new solutions, such as, I don't know, green data or whatever. But where we are using it already today, it makes sense. So it helps us to accelerate also the development. It helps us to create a stronger algorithm. It helps us to also get more and more inspired from the outer world, which can be startups. I think it's not necessarily only linked to startups purely. So there are a lot of people outside who can actually enrich the solutions. Of course, we are not that used to it, so we still have to learn, I guess. But I see it coming more and more. We just created a Center of Excellence for open source purely. So you see that the company is also kind of dedicated to go in that direction. And I think it will be a learning exercise as well during the coming years, but a promising one. And just to also come back to it, the more we are talking about something new to develop, the more it would make sense. If it's something that we already know quite well, where solutions already existing, I guess we would go more for the integration instead of developing something new. And I could also well imagine to link open source projects more and more also with our internal incubator, where we develop ideas from business people, actually. So they are providing ideas that can be developed in a kind of a prototype in just a few months. Why not just opening up this to the outer world as well? Saying, okay, we do this open source with our own developers. We get help from startups who have already some good skills in it, some good capabilities in it, and we do it open source, so we do it together. And I could even think further to also open it up to an ecosystem which is consisting on startups as enabling partners, but also eventually vendors, universities, or other like utilities. So these are my thoughts on it. So.
Thanks. Probably similar, Peter.
It's if I should, I agree with Eva's points here to a very large extent. If I should try and add something to that from my perspective, I do think that there is this speed of change. I think, again, coming back to that, which if we work together, if we share ideas, if we do not reinvent the wheel too much, I think there is a lot of gain to get there. I also think, at least from our side, we come from an experience of we are looking at open, both open collaboration, but also open source as something on the way to standardization. If we are not really there, and if it's not relevant to standardize a certain component or method or procedure, then open source could be in relevant cases could be like as close as you can get. We from a utility side and talking specifically from our Vattenfall distribution experience, a decade ago we had around 40 different ways of communicating with our substation that has been evolved over, of course, 30, 40 years, but it was mostly proprietary protocols from different companies, from different countries, which ended up being something completely unmanageable in the end. And there, the value and really the drive for standardization had its start. And I think open source and developing in general in a collaborative way is our way of trying to standardize and not being too unique if there is no specific reasons for it. So that I would say maybe is another angle as well, in addition to what Eva said.
Yeah, that's great. And I'm going to go to Dean in terms of thinking about the role of open source and open systems, and when you're thinking about investment opportunities. Erica, I'm gonna skip you on this because we're running out of time, but I think you answered this question in terms of creating opportunities for technologies to link into ABB technologies and making sure that the interoperability is there and there's opportunities. But Dean, maybe you can provide a quick perspective here. I want to make sure that we pull this together before we do the pitch sessions here.
Yeah, no, my brain was going there a little bit, Mark. I mean, this is I think in terms of open source from a startup perspective, yes, it's something that we certainly have got companies, startups invested in and around the open source ecosystem. Definitely, we've got some companies that are very much kind of creating the core of their innovation within those open source communities. On the flip side of that, we have also got, of course, a lot of investments in the cyberspace, because obviously the flip side of that open source and obviously contribution from potentially anywhere is, as we've seen recently with, you know, the vulnerabilities and very public vulnerabilities, it does open us up to the opportunity of, let's say, people contributing who don't have honest intentions. So I think that's something you've got to be mindful and careful of, as you really do open up that, especially in the current climate. Of course, you know, it's you know, there obviously are state actors who are looking to, you know, actively cause issues in certain areas. So you know, we have again got investments in the space that look at things like bill of materials and where does your software actually come from. But I think obviously as long as you've considered that, and as long as you've got an ecosystem that also focuses on that side of things, that's also very important, though. I think that's the point I'd make. You do want to make sure that you do understand where things are being created. You know, because especially given the industry we're in, right? You know, when you're dealing with critical national infrastructure, it's obviously a hugely important thing. And you know, I'm sure Erica, you know, would have to have a, you know, a myopic focus on this and understand where the source of things, let's say from an ABB perspective, are coming from, because of the, you know, the types of things that ABB are creating on you know, infrastructure for all of our countries. So I know I haven't really answered the question there, Mark, but I guess it's just a couple of areas that I think
very good
are really
cautionary aspect of it, you know, as a minimum.
I do want to balance it with that positive side, though, Mark. That's it. You know, I don't want to be the bearer of doom.
Yeah, that sounds great. And I think organizations like LF Energy are trying to figure out how to get around some of those limitations and provide a little more structure and support. I leave Fernando to take the last comment here. And then I'm going to encourage all of the panelists to participate in the chat and ask questions of the pitch of the startup companies as we go into the second part of this. Fernando, you want to wind things up for us here with any comments about NL innovation hubs and open source systems, or is that getting down too much of a rabbit hole for us?
Regarding open source, I think I'm afraid we are not working on that way. I'm not in the IT area either, so I wouldn't be sure about that either. But I would say that we work on a collaborative way with the startups. We do integrate with their systems. We do want to bring their solutions into our solutions in a double way, let's say. But that is different from open source, of course. So it is more integrating their solutions, their algorithms, whatever they are doing that is valuable into our processes and products. We have seen a huge development in Europe and in other ecosystems. Europe is my main focus regarding artificial intelligence-based solutions. You know, so it is more and more what we are bringing in to improve the way we do operational maintenance, the way we do construction, the way we do our different processes. But again, always in a collaborative way of doing this with the startups developing the solutions, but probably not working on open source. And I think it is mainly because of what Leon was mentioning about cybersecurity. We're very concerned about that.
Hey, let's keep this discussion going on in the chat as we turn things over to Annalise. I don't want to, we're going to be in a very tight timetable to get all the pitch sessions in today. I'm very excited about listening to them, and one of the main reasons why we pulled this session together. So I'm going to turn it over to you, Annalise, and we can go into the pitch sessions. We can,
Wonderful.
I know that the Slido
Thank you.
participation is kind of weak, so we revisit
Yeah.
that.
Yeah, let's do that. And I will invite the panelists if they can give their perspective, because then we can have everybody's opinion there and see at the end of the pitch session. Thank you very much, Mark. Thank you all the panelists. Really appreciate it. I'm going to start because I want everybody to have a chance to really do their pitch today. So we have quite a lot of interesting company. And I'm going to be the first one. I'm going to talk about Incubate Energy. And so I'm going to time myself as well to make sure that I'm doing the 5 minutes. And after me, I expect Marcel to jump on on the slide and do holotron. So I'm going to start my 5 minutes now. So here, before I jump into Incubate Energy, I really wanted to talk a little bit about EPRIM's mission. I want to make sure that everybody has this understanding that EPRI is independent, and that means that we're looking at the best technology without specific interest, but really trying to make things moving forward in the right direction. And then we're non-profit, so we're not trying to gain any money out of those new technology. All the money that is earned by EPRI is really going into reinvesting into more research, and our approach is really collaborative. And I think today it shows that we are making utility talking with each other. We like collaborating with all the utilities, the startups, and that's really important for us. So now Incubate Energy, there's two parts of it. The first part is Incubate Energy Network. So here you see a beautiful map of the US, and you may think, why am I showing the US? It's not our interest today, but it's to explain you a little bit the history here. It started with DOE funding. So in the US, they had a huge network of incubators and accelerators working together, sharing best practices, and my role is really to develop this internationally. So please reach out to me if you think we have more people outside of the US that can join us. And then next year we'll have a better map of outside of, of the US. And you can see there's already 3 participants in Europe. What is then Incubate Energy Lab? This second part. It's an open innovation program linking startups in the network that you just saw with utilities to demonstrate and scale innovations in decarbonization, electrification, grid modernization, and resilience. It's done in 5 stages. First one is identify. We work this year with 17 utilities. It started with 7 utilities in 2019. You can see them on the right side. And with all of them, at the end of last year, we sat and identified priorities for 2022. We came up with a couple of challenges that you see here. And what we did is we had a challenge online, and utilities, startup were able to apply there from mid-December until mid-January. Now, currently, we are ending our discovery phase. So we had 114 startups that applied to our program this year. You're going to hear the pitch of a lot of them today. And with those startups we review, we have the EPRI subject matter expert, SMEs, that are reviewing all the technology, all the application, as well as all the SMEs from the utilities. And then with all the scoring of all the subject matter experts, we can establish which startup is more likely to do a project with the utilities. We have this year the objective of maybe 15 to 20 projects, and we're hoping to have some of them in Europe. The main part here is the engaging part that we are starting right now, where we are really trying to tackle which startup is going to be which project with which utility, and our strengths is really helping to do rapid contracting and making sure that we are scoping properly the projects. Then the next phase is the activate phase. This is a 16-week rapid innovation assessment. So our goal really here is to make sure that there is awareness around the technology, that the startups is engaging with the utility, and help them to define potential future projects. You can see all our projects that happened last year and the year before on the website. So I would invite you to follow the link, and I will share it on the chat afterwards. What's important for us is really to scale, and so the scaling part is really opening those projects to everybody. So we have a demo day in October with final presentation. At that event, we invite all the utilities that are member of EPRI. That's almost 500 utilities all around the world. And so we make sure that we are sharing all the learnings from all those projects. This is why you can see everything online. So if you go to our webpage, you're going to see all the projects, all the presentation that were done, and then the final reports. Finally, to show you that we are scaling up and bringing some startup to market, I can tell you that in 2019, out of the 7 startups that participated, 1 of them was acquired. In 2020, we saw 70% of traction by demo day, and last year, 12 out of 20. I'm running out of time. There's only 10 seconds left for me. So here's our contact if you want to contact us. And thank you very much. So now I've done my time. I'm gonna pass on to the next one. So if Marcel from Holotron can follow up, it will be amazing. Feel free to send me questions on the chat. I will share the link on the project there. And thank you very much. Go ahead, Marcel. I'm gonna put you a 5 minutes timer. I'll do a 1 minute chat. 1 minute. Yeah, go.
Okay. Hi. I'm Marcel Ries, and today I want to talk about Lifelike control of humanoid robots and computer avatars. So we have an interesting situation that we are already having this Herculean feat in front of us of sustaining the world with energy, but now even bigger challenges are being thrown upon us. And so we have a challenge. We have to maintain the existing infrastructure, and on top of that, do humongous upgrades in the energy and in the grid. There's a lot of other infrastructure unrelated to utilities that needs to be upgraded or is failing right now. We have an aging society, so less available workers, and the people who do work rather want to work from home. So what can we do to do everything faster and better? Do we just use robots? No, because robots are dumb. Actually, do you see this little box here?
Yeah.
Okay.
Well, no, I don't know. We see your presentation.
Okay, good. Yeah, so this is the Holotron. It's a full body interface to control robotic avatars and virtual avatars with force feedback and balance feedback. That means you just control the avatar by doing what you normally would do. And by doing that, now you have suddenly a robot that is as smart as a human, because it's operated by a human. It's as fast as a human, but it can be stronger than a human. You can use humanoid robots as vehicles, because the robot can be somewhere else, and suddenly you feel as if you are somewhere else. So essentially like Zoom for the entire body or reality. And then there's this vision of the holodeck, the perfect virtual reality that you can touch. But actually the Holotron is the reality of perfect VR that you can touch. So you can feel and control all forces in VR. You can feel and control moving objects. So it's much more realistic. You can walk, climb ladders, crawl or run. You can do anything in VR just in real life. So that is essentially like Zoom for the body to VR. Now, this is the first prototype of any system for realistic walking in VR with force and balance feedback. So if I kick this ball, I feel that. If I walk over these rubble blocks or get kicked by blocks from below, I feel that as a whole body sensation. But also in the legs, if I fall down a step or get hit by a chair, I feel that as a whole body sensation, and I can control it with the legs. It's a very fast and accurate system, so I can already use it to go skateboarding in VR, again with balance and force feedbacks for the legs. And if I have a crash in VR, I have a crash in real life. Well, in the system. So you can use it to control vehicles. It could be something like this, it could be smaller, where you can even be upside down, so you can crawl, jump, do anything in VR as in real life. And there are other versions of this that can be as small that you put it, so small that you put it, have it at home. The exoskeleton is super mobile, so that you can have really full range of motion. This is not completely integrated right now. So all the hard problems of this are solved. It's easy to extend to the whole body. And so now how can that be used? For example, in hazardous environments, they become safe. You can have a robot in there. So you need less staff, less supervision, less bureaucracy. So effectively, you can multiply the workforce. So you can easily work in tight, hot, suffocating, toxic, radioactive, or in bad weather conditions. You can change shifts without delay because the robots stay on site. You can turn dirty and risky jobs into high-tech jobs, so you have more available workers who are interested in this. You can reduce exhaustion and illness because the robot can be stronger than the worker, so you have force augmentation. You can instantly work from one location, then on another one, might be on a different continent, so you have a much larger flexibility, how to use your workforce. It's absolutely available for unstructured work environments. So compared to other robots that need some structured environments, you can create superhuman performance, but you can also have tiny robots that go like into tighter tubes. So it's enabling an aging workforce, so older people can still work. It's perfect. It allows for perfect monitoring and documentation of all tasks because everything can be recorded. And for example, eliminate transportation if you want to work on an offshore windmill, for example.
5 minutes. I'm afraid you're over. I'm sorry.
I didn't see.
Yeah.
Anyway.
Sorry.
Okay.
But I will invite people to ask questions and also connect directly with you if they want to see more of your pitch. I'm sorry that I had you to cut off. I tried to make a sign. I thought you saw me. Now we have.
This box is kind of popping up in my window all the time, so it's kind of annoying.
I'm sorry to hear. Now we have Rated Power Ignacio. Thank you. Thank you very much. Ignacio, can you take the control? Yes.
Thank you very much. Yeah.
And the next one will be Enigmedia.
Great. Hi, Annelies, can I start then?
Yes, please start.
Perfect. Perfect. Hello, everyone, and thank you all for attending this session. My name is Ignacio Granda, and I work as a business development manager at Rated Power. And I'm very happy to be here today to be able to share with you our story. So at Rated Power, our 3 co-founders worked for several years developing utility-scale solar plants all over the world. But to get just one project done, they could spend weeks, even months, sometimes calculating formulas and algorithms and generating hundreds and hundreds of pages of engineering and documentation. And that is because traditional workflow for solar plant feasibility, basic and digital engineering requires a lot of back and forth. So one day they thought, how could this whole process be streamlined? Could this process be integrated into one solution? And surprise, surprise, it could. And so that's what we did, actually. We offer a comprehensive software package called PV Design, which streamlines processes in one platform. By scanning millions of iterations, it instantly optimizes the plant design and automatically generates all the engineering documentation that you require. So in other words, we transform 6 weeks of work into only 2 minutes. We decrease the cost of energy generated by 5%, which translates into 20% higher profitability. And this is our software PV Design. It's very easy to use, as you can see. You just have to create the site and upload the project location into the software. After which you can select the main criteria of your PV plant, such as civil parameters, the electrical configuration, or the equipment as well. And last but not least, in just a few minutes, you obtain an optimized layout and you can download all the documentation generated, such as the bill of materials, the energy production, estimates, and much more as well. And we're constantly evolving. For instance, during the past months, we have added an Earthworks tool, a CAPEX tool to calculate the LCOE, and east-west structures as well. And to date, there is no other software to fully carry out the design and engineering process as we do. There are other tools in the market that only automate specific parts of the process. Our software also possesses particular characteristics that make it unique. First, it is a collaborative tool where our clients can add as many users as they want for teams and business units. It is also a cloud-based software, which will allow you to work from any device from anywhere in the world. It is also globally accepted, so data and insights follow domestic standards. And the software and documentation are also available in 6 different languages. And finally, we offer our clients unlimited iterations as well for their plans to unravel the best configuration possible that they can have. So our different customers are all the key different players in the solar industry, and we cover a big chunk of the whole value chain. We work with utility companies, solar developers, EPC companies, engineering and consulting firms, and even some manufacturers as well. So our business model is a software as a service based on annual subscriptions. And we offer a 14-day free trial with full support, of course, before purchasing, so you can test out the tool with your own projects as well. Now, some numbers. In the last 5 years, we have acquired over 120 customers from all over the world. And we have worked with 1,300 users who design with our tool on a continuous basis, and which has simulated over 7,000 gigawatts using PV design in more than 150 countries. And now let's talk a little bit about our future. So we have been backed by Seiya Ventures with a $6 million Series A, and we want to become the standard in an industry that is doubling its size every 2 years. And this is just the beginning. We believe in a future, the same future that our customers believe in, which is not just about solar. We want to keep developing our tool and working on it. And this year we will be integrating over headlights in our software, as well as batteries in PV design, among different new features. And in the long run, why not residential, CNI, and even expand to other renewable energies such as wind. Radiant Power's ultimate goal is to provide accessible green energy worldwide, mixing solar, wind, storage, and grid all in integrated systems. And this is where we're headed. And we have the right technology and also the right team to do it. Thank you.
Perfect, you're on time. Exactly on time. Perfect. Thank you very much.
Thank you. I'll be happy to take any questions afterwards.
Yeah, in the chat otherwise. So now, here we go. Any media. Next one would be Energy Dome, Rembrandt. Thank you. Go. You can start your 5 minutes now.
Enig Media, I think, Annelies.
Yeah, Enig Media now, and then you're next. Okay. Okay, 5 minutes, start now.
Okay, thank you. So thank you for inviting us to this event. I am Gerard Vidal. I am the founder and CSO of Enig Media. I'm a PhD in physics. I started my company, Enig Media, 10 years ago. Now we are backed by a couple of venture capitals, and we are now exploring the new fundraising round. I hope to close it next week for more than 50 million. So let's see. Well, what we are doing in Enig Media, we are an industrial cybersecurity company. So the problem that we are trying to solve is the following. Most of the time, we are talking about increasing the cybersecurity. That's really easy to do when we are in IT or we are designing a new plan, but it's a nightmare when we are talking about brownfield, about those installed base facilities, those grids with a lot of years, lifetime of the materials in an energy grid could be more than 30 years, 20 years, 40 years in some cases. So how you protect that devices that were designed before internet exists? That's the main issue that we are trying to solve. Our approach is totally different to the most extended solutions. What we are providing is prevention. We are trying to avoid cyber attacks. People used to, let's say, detect these cyber attacks, but we prevent before they happen. So what we do is we secure all the communications that you have in the industrial field. We don't care if there is proprietary protocols. We don't care if there is a specific vendors. So we are totally agnostic. How we do that? We deploy your solution. We have hardware appliances, something like that. That can be, it's a cost of the shelf hardware, right? And we can deploy it in the field, but also we have virtual appliances. And what we create is an overlay of encrypting the communications. So thanks to this overlay, what we are doing is armoring the network. A potential attacker cannot guess which are the devices that you have in the field. So they cannot make an attack to your devices. Even they cannot exploit the vulnerabilities of your legacy devices. And the most interesting thing is that we can deploy the solution in a couple of minutes. So how we do that? Well, basically, there's a lot of solutions, a lot of vendors that maybe you know, like Dragos, Nozomi, Clarity, etc. And they are above on the, let's say, more near the IT side of the infrastructure, but we are in the OT. We are really in the substation level. We are in the field level, and what we create is this kind of overlay of protection. So thanks to that, we can deploy and we can bring protection immediately. So just to give you an idea, in only hours, we can deploy your solution and you can see the value. I will show you an example of a critical infrastructure that we deploy our solution in 3 different sites in just 2 hours. Also, what we are providing is an active protection, and we are bringing all the compatibilities, and we are comparable with the solutions that I told you before. Right? To give you an example, that's a real example that we have done with a well-known renewable company that we have here in Spain. We have protected a solar park with all devices, and we can separate, segmentate, and provide the security according the well-known standards. It is important to mention that usually you cannot do that because there are specific protocols in the energy grid vertical, like IEC 61850, that have strong requirements of latency. We can bring this kind of protection with a latency below 1 millisecond. That's the thing that it's unique from our point of view. That's an example that I said before. That was a critical infrastructure here in Spain. It's a petrochemical plant. The plant only stops 48 hours in the full year. In this 48 hours, let's say the cybersecurity time frame is just a couple of hours because it's not so critical that the ability and the production. So we are able to deploy our solution in just 2 hours in 3 different sites spread by 3 kilometers. The system integrator, which is certified person, can do that, not us. So that's just an example of what we can be able to do. And that's the last example. We are deploying our solution in more than 500 stations here in Spain. So we scale globally. What we want, just if you're interested, we can share with you some boxes with no charges, and we would like to receive your feedback. So thank you.
For 27 seconds to, if somebody wants to ask a question very quickly. Otherwise, we move on with the next one.
Thank you.
Thank you very much. Brandt, you want to go?
Yeah, I think you need to give me control of the screen.
You just need to share at the bottom.
Yeah.
Okay, in your 5 minutes, we start now.
No problem. So my name is Rembrandt. I have been 15 years at GE, where I led the global project development group for GE Energy. Now I'm the CCO, the Chief Commercial Officer at Energy Dome. And Energy Dome is a fast-growing company in the long-duration energy storage space, based out of Milan and out of London. When we talk long duration, we're really talking about 4 to 6 hours when it is difficult to get to economic returns with lithium ion storage technology. Company was only founded 2 years ago. We're growing very fast. Like I said, we're actually more in the scale-up than in the startup mode at the moment. We did a 10 million Series A that was 5 times oversubscribed. And we were recently named by BNEF as a finalist in their BNEF Pioneers competition. What you see here is that we fight CO2 with CO2. What's that all about? That is about the storage technology that we have here that we call the CO2 battery. I will just explain it here in one page. Left top, you see a schematic of the process. We will share the pages afterwards with those interested, and if you click on the link, you'll see the animation. But what you see, in effect, is a very large dome on the right that holds industrial-grade CO2. To the left of that, you see a turbine. In the middle, you see a motor/generator. Left of that, you see a compressor, then a thermal energy store, and the CO2 vessels. And we store energy by drawing CO2 from atmospheric pressure at ambient temperature, compressing it to 70 bar, at which point the CO2 goes liquid, and it is stored in the CO2 vessels that you see on the left. You want to get your power back, you simply reverse the process, you pick up heat that you stored earlier, the CO2 then has to expand and does so in the turbo expander before flowing back into the dome at atmospheric pressure and ambient temperature. What's unique about the system is that all the components are off the shelf, all the processes are well understood, and it comes actually with performance warranties from a well-established global supply chain. Other people have done something similar. I won't go into all the detail because it's a bit of an eye chart, but the adjacent technologies, if you will, are compressed air and liquid air. But what you see here, that if you compress a kilo of air, you end up with very low energy densities and very high volumes. Liquid air, on the other hand, is attractive. The volume is very small, high energy density, but the -190 is problematic for materials and for your round-trip efficiency, which is very low. CO2, by comparison, actually goes liquid at ambient temperature at 70 bar. So we combine the best of both worlds. So if you look at the comparison to lithium ion right up on the right bottom of the page here, we see a 80-85% RTE in lithium, and we have a 70 to 75% round-trip efficiency. The big difference being we have no degradation in round-trip efficiency nor in usable capacity. And oh, by the way, we have a lifetime that is 2 to 3 times that of lithium and a capex that's about half. So says who? Says we are actually just building the demonstrator. You see it here in construction. We anticipate commissioning it next month. What you see at the bottom, of course, is the dome. It is very large. Left top, you see the compressor off the shelf from Cobelco. Right top, you see the thermal energy stores. And yeah, the plant is being commissioned next month, and we are open for orders. So I'd be really interested in talking to parties who want to participate in either the Catalyst program or in the Recovery and Resilience program in either the US or in Europe. My contact details are in the pitch. Happy to take questions afterwards or offline. That's me.
Thank you. Thank you very much. Yeah, we have 30 seconds if somebody wanted to ask a question. Well, otherwise we move on with Matthew from Ionet, and after him it would be Krakenflex. Thank you very much.
Okay, good afternoon, everyone. I'm Matthew Williams, founder and CEO of Ionet. At Ionet, we've developed a new class of hardware device for the distribution grid, which can resolve all critical power flow issues in a single, affordable, and reliable device. And the reason that we need this is because the energy transition is fundamentally changing the way the power system works. Innovation at generation consumption has far outpaced grid infrastructure, and the two current options for upgrading grids are to layer expensive electronics on top of the grid, or digitalization, which can provide insight but not necessarily resolve the problems underneath. Both these options are far too expensive and complex for the long-term security and viability of our electricity system. But still, to manage the grids and keep the lights on, DSOs need visibility and control. So at Ionet, we looked at the grid from a systems design perspective and set out to enable this control from within. So our solution is hardware-based, and it's a hybrid intelligent transformer. So it's a drop-in replacement for a traditional transformer at a similar size and cost, and we provide that role of the transformer, but on top of the voltage step change, we also deliver voltage control independent on each phase, plus or minus 10%. We completely remove harmonics, and we correct power factor. And these are really the three things you need in the power system. And doing all of this within a single device means we remove the need for lots of other expensive add-on technologies such as tap changers, harmonic filters, and fax devices. The reason that we're able to achieve all this functionality so much cheaper is we control the power through the magnetic domain. So we still have an electromagnetic core and windings, but we add a small local controller and a small amount of power electronics. But our electronics aren't connected directly to the grid, they're galvanically isolated. And this allows us to scale up to grid power levels with the electronics staying really, really small and therefore much cheaper. It also means if there's any issues with the control or the electronics, we can go into a bypass mode and act as a standard transformer. So we're not introducing any new failure modes into the system. The device is autonomous with local monitoring control, but of course can be connected back to any SCADA or ADMS system. So we can provide that real-time visibility and operational data and feed into things like better voltage control schemes and even predictive maintenance. As a hardware device, it meets all of the eco-design standards and existing technical requirements for a transformer. And from an OPEX perspective, it can be treated in pretty much the same way as a transformer would. So you can replace a single device and it immediately resolves all these technical issues. But what's really cool is when you have multiple devices within a system, we can coordinate and control them to provide system optimization. And because we have this control, this kind of analog control capability that responds and settles in under a millisecond, we can do things like improve overall grid efficiency. We can allow much more DERs to be connected. And really, it's about unlocking this flexibility from within the grid rather than having to rely on all these external parties to provide it. So we've had independent power system studies completed on the hardware where they looked at replacing transformers with Ion8 devices and no other changes to the network. And in those studies, it showed double-digit increases in allowable DER penetration like EVs and heat pumps, rooftop PV, big increases in total transfer capacity, and a significant reduction in total system losses. So right now, last year we delivered prototypes, and at the moment we're finalizing commercial scale devices with our manufacturing partners. Of course, if anyone's interested in live demonstrations of the prototypes, please reach out. More than happy to arrange that. We're now entering the pilot trial phase.
1 minute.
Towards the end of this year. So our hardware is applicable anywhere power flow control is required, but we're initially working with distribution grids and renewable generation. We have our first couple of pilots lined up with DSOs and renewable developers, but we're currently looking for more. And so one of our main goals is to ensure product market fit. We want our partners to have input into the final product specifications, and we can even prioritize certain products and capabilities on our roadmap. We welcome interested parties to reach out for more technical information and discussions around this potential collaboration, including business case analysis and testing and trials. You can contact us through the website or me directly at the email shown here. Thank you very much.
Wonderful, right on time. Now we're gonna have Kraken Flex, and then following will be Encore. Thank you.
Can you see the screen now?
Yes.
Okay, great, perfect. Hi, so I'm Charlotte Johnson and I'm Chief of Staff at Kraken Flex. Before I go into a bit of detail about what we do at Kraken Flex, I wanted to give you sort of a background overview to the Octopus Energy Group, who we're part of. So since launching in 2016, it's been a really busy 5 years, and the Octopus Energy Group is made up of 9 businesses across 8 countries. And the business I'd like to talk to you about today is Kraken Flex. And we're a software platform that are currently managing and optimizing over 4 gigawatts of power, and that comes from large-scale storage, solar and wind, and also commercial industrial demand-side response and domestic heat pumps and electric vehicles. So I'd first like to reflect on the energy transition thus far. The energy system has been historically dominated by large-scale centralized generation that flowed from the transmission network to the distribution network and then to the end consumers. Energy traders only needed to connect to a small number of generation assets, and these assets provided not only energy, but also inertia, reactive power, and stability to the system operator. Today, the system is significantly more distributed. Generation still flows from large centralized generators, but also from embedded solar storage and wind, and even localized storage wind as well. The bidirectional flow of energy requires real-time balancing, and it is only going to get greater in the future as we electrify heat and transport. So the industry is going through a period of rapid change, and as we get more and more distributed energy resources of any size and scale, the systems that are used to control and manage and trade them across multiple markets are becoming more manual and cumbersome, and more importantly, ill-suited to support the energy transition. Kraken Flex simplifies the complexity of this problem and centralizes all these systems and processes into one smart automated platform. We're currently working with 4 key customer groups to provide a solution that reaches all corners of the energy ecosystem. For asset owners, we manage, monitor and control their portfolio of assets, and we then connect them digitally and in real time to the customers on the right-hand side, our traders. So on the right-hand side, you have traders and off-takers who use the platform to access a variety of assets and to optimize them in a scalable manner. On the bottom right, you have retailers who we help unlock the value of flexibility through offering unique and innovative tariffs. that optimize and control domestic assets such as electric vehicles and heat pumps. And then finally, on the bottom left, you have system operators, who we work with closely to access grid edge assets, monitor network constraints, and manage frequency and falling levels of inertia. So we do all of this through our 4 core modules. The modularity of the platform allows our customers to specify which modules they want to procure and also the features that they want to procure within that module. The core modules we have are, firstly, control and dispatch, which is the real-time dashboard monitoring view our customers get access to, and it gives them all of the data in real time and also APIs as well. We then have events and notifications, which is an automated module. It allows customers to raise alerts off the back of the real-time telemetry data that's coming through, and they can configure those alerts based on the asset's physical or financial performance. These alerts can then be routed to third parties and escalated. Thirdly, we have optimization and modeling, which includes our virtual power plant capability, and it allows users to optimize a large portfolio of assets against a given objective function. And that objective function can be something from market prices, network constraints, or the carbon intensity on the grid. And the optimizer does this while also taking into account the physical constraints on each of the individual assets. And then the final module that we offer is called reporting and analytics. And customers here have access to our data lake to produce their own physical and financial performance-based reports. In summary, our vision is to really be at the heart of the technology that enables the energy transition. And to do this, we are asset agnostic, manufacturer agnostic, and size agnostic. We've contracted with over 4 gigawatts of power, ranging from sites that are 1 kilowatt in size to 100 megawatts. And we can integrate either by a cloud-to-cloud integration, direct enablement, or, where required, the Kraken Flex Gateway solution. In summary, we're really excited to work with like-minded companies that want to accelerate the journey to net zero. Please contact me if you have any questions about the solution and some of the work that we're currently doing at the moment. Thank you.
Thank you. Wonderful. Right on time as well. So now we're going to have Encore. Okay, and your 5 minutes starts now. Okay, we don't hear you.
Hello,
I don't know if you're talking. Okay.
Can you hear me? Yeah. Hello,
Yeah,
everybody.
thank you.
Hello, everybody. My name is Corbin Pambu. I'm the co-founder and CTO of Acsr. Acsr is a software company that provides solutions to decarbonize energy networks. We are based in Germany and in the US. Network planners and operators must find new flexibility and storage sources to decarbonize their energy systems. These flexibility and storage sources are typically at the interface between different energy sectors, meaning to model the different energy sectors, we have different interfaces between the energy networks that are facilities like power to gas facility, power to heat facilities. Now, in order to model the energy networks of the future, we will have to model them in an integrated manner. But if you look at current solutions, they consider the energy networks in a more individual way and not as a whole. So if the network operator wants to model the energy networks, they have to iterate between different simulation software, which can be very time-consuming, cost-intensive, and error-prone. I was faced with the same problem when I was working on my PhD, where I was given the assignment to model the coupling between gas and electricity networks in terms of security of supply. And because of lack of tools that allow the coupling between these two networks, I decided to develop a software application called Saint. And Saint is a software platform to run physical simulations and optimization models of coupled energy networks and markets. What differentiates Saint from other existing tools is the fact that with Saint, you can model the energy networks in a coupled way. In addition, we allow the integration of meteorological data sets, so you can run renewable integration studies using the software. And in addition, we allow the modeling of markets and physical networks, and by doing that, you can find the best trade-off between cost and reliability. Here's an overview of our current simulation optimization models in SAINT. So we have electric network simulation and optimization, where the user can run AC power flow or a production cost model and iterate between them. We have gas network hydraulic simulation module, where the user can model the blending of hydrogen into the gas network or pure hydrogen networks. And in addition, we have a module called coupled electricity and gas simulation, where the user can consider the different coupling points between these two networks at gas-fired power plants, power-to-gas facilities, and electric-driven gas compressor stations. By using SAINT, the user can better inform planning decisions to reduce capital and operational costs, to increase reliability and resiliency of their energy networks, and to enable solutions to achieve decarbonization. This slide gives an overview of our customers and how they are currently using SAINT. I want to focus on two of our customers. For instance, the Hawaiian Electric Company. We did a project where we performed a novel generation resource adequacy study to help them analyze the impact of replacing their last coal power plants by PV and batteries. And in these studies, we run multiple thousands of unit commitment and economic dispatch model to inform their decisions on how to replace their coal plant. Then TenneT is the electricity transmission system operator of the Netherlands and parts of Germany. They use SAINT to find the optimal location and the sizing of electrolyzers. And these are also the other customers and use cases that are mentioning here. We are currently looking for collaboration opportunities with industrial customers, in particular network operators. And if you are interested to have a live demo of SAINT and have any additional questions, please feel free to send an email to kp@encord.com. Thank you very much for your attention.
Thank you very much. That was great. Now we have Manifold, Jeff. Thank you. And the next one would be Jason with the TS Conductor. Thank you. Your 5 minutes can start now.
Okay, thank you. Hi, I'm Jeffrey Lett with Manifold Robotics, presenting from Brooklyn, New York. Today, I'll be talking about a product we're developing to improve drone operations near power lines with EMF data. So drones are becoming more and more popular for inspecting power lines, but at the same time, power lines pose many challenges for drone operations. For example, when manually operating a drone, it could be difficult for the pilot to accurately gauge the distance between the power line and the drone visually, particularly when they're trying to do an up-close inspection without getting closer than a utility's defined minimum approach distance. And it's also difficult to automate flight near power lines, different from surveying like a farm or land or something like that. We're trying to fly a drone around a set of very thin conductors that conventional obstacle detection sensors often have difficulty detecting. And finally, the linear nature of power lines often requires being able to safely fly long distances, which in itself can be a very challenging problem. So to address these problems, we've been developing a new technology that acts on electromagnetic field data for positioning and navigation of drones near power lines. Energized power lines conveniently emit strong and distinct electromagnetic fields at a known frequency, 50 hertz in Europe, 60 hertz here in the United States. And by measuring this data in flight, a drone could estimate where a power line is and what direction it's going with respect to the drone. So in a sense, the power line can act as an active beacon of sorts that emits a signal that could be useful for a drone to estimate its position. And all power lines obviously already emit these signals, and our technology is turning that into useful information for drones for navigation. We've been developing this product over the past 2 years in collaboration with the largest public power utility here in the United States, the New York Power Authority. And in this photo, you see our sensor payload integrated into a commercial drone, and it consists of an electric field sensor and a magnetic field sensor. And what the payload does is measure the electric and magnetic fields, analyzes that data in flight, and produces estimates of power line proximity and orientation to the drone, so it can use that for making intelligent decisions, for avoiding collisions or tracking power lines. We're aiming to begin deploying this technology this summer for pilot testing to demonstrate how the product can deliver value to utilities in streamlining the inspection process using drones through two primary use cases. In our first use case for close-up inspections, our product can use EMF to prevent collisions with the power line and enforce a minimum approach distance so that pilots can perform inspections with greater safety and confidence. So you're taking away the worry of accidentally crashing into a line when manually operating a drone close to a power line or transmission line. And the product can also support the automation of shot sheet-based inspections, where instead of having to manually position a drone at various positions along a power line or a tower that supports a power line, say from beside or directly above it, the sensor payload can look at the EMF data and position the drone at certain locations based on that data autonomously. And in another use case for long distance inspections, the drone can navigate along a power line using the EMF that the power line is emitting. So it's using it as a guiding signal to fly along a line. And we can also define, thank you. And we can also define an outer EMF barrier that should contain the drone's airspace to reduce risk associated with the operation and maintain a shielded airspace. So this has potential to appeal to the SORA model and ensure safe beyond visual line of sight flight by offering a backup to GPS-based navigation, whereby if your GPS fails or GPS loses signal, you can still safely navigate along a power line just by looking at the electromagnetic field data. And to paint a complete picture here, using EMF data, we can again make sure we're not colliding with transmission lines, while at the same time we're not flying off into uncontrolled airspace where there might be other airplanes or people on the ground, and significantly reduce risk with all of these operations. So thank you all for listening, and I'd like to hear from anyone who's interested in this technology. So here's my contact info. We'll be doing pilot testing this summer, so please get in touch if you'd like to participate.
So you already have a question there that you can, I invite you to answer on the chat. And now we're gonna move on to TS Conductor to make sure that we're on time doing all the pitches. Thank you very much.
Should I start?
Yeah, please start now. Thank you.
All right, thank you. I really appreciate EPRI for making this opportunity available to TS. We're also blessed with friends like Dean and visionary leaders like JP at National Grid. We're also appreciative of Breakthrough Energy Venture and Nextera who invested in our company. I wanted to start with the statement that electric grid is a major bottleneck to decarbonization. There's probably no dispute in the audience here. When you think about renewable generation, these are often in remote locations, and they have to be transported. The electrons have to be transported to the load center. But our grid is still featuring a 1908 technology, the ACSR technology. And when you think about renewable integration, in the US, 90% of that is basically stuck, cannot be integrated to the grid because of limited bandwidth. The average wait is about 4 years. And there's another issue when you use the old conductor technology, it's not efficient. Globally, we're wasting 2,000 terawatt hours of electricity every year. To compensate for that loss, the compensatory generation alone is responsible for a gigaton of greenhouse gas. And we also have an aging grid. The extreme weather is posing additional constraint. There's greater need for resiliency and reliability for the power grid as we are becoming even more dependent on electricity. You know, when you think of a typical transmission project, only 5% of the project cost is on conductors. Yet, the conductor dictates what is the throughput or capacity and what is the efficiency. I would argue that a better conductor is needed to address our needs and the issues in front of us. When you think about a conductor, there are two elements in it that's important. The conductive element, which is typically aluminum, and the strength member. The yellow row in this table here is the Acsr technology. It features high-strength steel and hard aluminum. Why hard aluminum? Because the conductor needed to leverage the strength from the hard aluminum, but it also limits the temperature the conductor can be used, and the steel is a very saggy core. And over the years, there's been a lot of work in terms of improving aluminum strength, but they all come at a price. That is electrical performance. So if you look for the best electrical performance, it is the annealed aluminum, has the highest electrical conductivity and supports highest operating temperature. And when you look at the strength member side, there's been a lot of evolutions over the years, but the best material that is available today, and that is what the material science offer, is the carbon composite. It has virtually no thermal expansion, only 20% of the weight of steel, and twice as strong as steel. When you think about it, even one of those three attributes are very desirable. To have all three together in one material platform, it is really ideal. When you combine the annealed aluminum and the carbon composite, which is in the TS conductor, that is the ultimate choice of material you could have from material science. And then the key is, can you also take care of the need for safety, reliability, longevity? And that is exactly what we have accomplished in TS conductor through that breakthrough design with design-in safety, reliability, and longevity. What we have done is we took advantage of the aluminum and we use it for electrical purpose, but we also use it to effectively protect the composite core. And that allows you to have the robustness in the field and be compatible with conventional way of doing installations. And it's shielded, immune from environmental degradation. We have some actual practical use in the field. This product has already deployed in both distribution and transmission circuits. And this is a typical example. By the way, reconductoring is the fastest and most economical way for capacity increase. We were able to reduce the CapEx by 40%, as well as the schedule by about a year. This is in Montana, Dakota. And we can go to a larger conductor to get you to about 250% capacity compared to the baseline and reduce a line loss by half. And this is what we are heading in the future. We have an optical fiber sensor inside the conductor so that the conductor is self-monitoring. It is aware of sag, it is aware of temperature, it is aware of strain, so you can monitor temperature conditions, conductor damage, vegetation accidents, storm events, in addition to sag compliance at all times. Thank you very much.
Thank you. Thank you very much. Now we have the last one, but not least, Novogrid. Paul, do you want to share your slide? And then we're going to be right on time. It's been a race.
Hi.
Hi, Paul.
I just landed in Edinburgh, so I am like super on time. I'm really proud of myself.
Okay. Well, I'm very glad you made it. All right, your 5 minutes are starting now.
Panicking. Anyway, okay, thanks. So Novogrid, intelligent grid visibility software is ultimately what we provide. We are a spin-out company from University College Dublin, so we're roomies with EPRI in Dublin. Myself and Professor Andrew Keane and Peter Richardson, three co-founders from it. We spent about 5 years developing the products, generated 2 patents, and now have our various suite of products installed in over 250 megawatts of generation in UK, Ireland, and Germany. So what the hell do we do? Basically virtual remote monitoring of the grid, but just using local data. Basically taking in data from a single point. That can be a generator, it can be a load, it can be whatever. Using our algorithms, we're able to get real-time power flow data on locations connected to that point many, many kilometers away without any sensors or communications out on the grid. The real power of what we're doing is it's basically power flow analysis at millisecond speed, and it's incredibly scalable. So what is it? It's, as I said, advanced set of grid state determination algorithms. It provides real-time power flow from using only local input data, so it's really, really light computationally. And I suppose the leap, what all those patents are about, is that it's a direct non-iterative calculation, which means you're always going to get an answer, and it's incredibly fast, and we don't require any additional telemetry. Benefits of it are it's incredibly scalable. We can add a wind farm or battery or whatever to our site, to our software package in less than half a day. It's incredibly fast. It's incredibly accurate. We've done many, many years of testing here in Ireland, the UK, with ESB networks and comparing sensor data from our IQ monitors versus ION monitors versus our algorithms, and the accuracy is pretty much the same. And it's incredibly cost effective. It scales and it doesn't require any additional measurement hardware out in the field. So off this grid visibility platform, then we're able to leverage a range of different products. So our first product was Grid Boost, which reduces line losses for generators. So this is installed widely across UK and Ireland, basically using the reactive power output of the wind farms to minimize the current and hence losses on distribution networks. And this is an incredibly popular product. It's another reason why I'm in Edinburgh selling again. Its big brother is Grid Flow, which effectively takes in the active power and the reactive power to minimize congestion on the network as well. And then we have our two new products, and I really just want to focus on kind of Grid Screen for now. I'll go through that a little bit later in the presentation. But we also provide Grid Cast, which gives real-time grid constraint data, primarily to energy trading desks, but also to asset managers, and that's a very popular product as well for us. Our customers, look, most of the big utilities, generators, those kind of guys. Grid Screen. So this is our new product. We're really excited about it. It basically helps project developers save time securing a grid connection. Big challenge, of course, is to reduce the number of iterations back and forth with the network operators and trying to find how many megawatts can you squeeze into a particular area. Everybody has these huge targets, so they're under huge pressure to squeeze these gigawatts onto the grid. At the moment, these iterative processes developer makes an application. It takes 6 months to get an offer back, and obviously the network operators can't optimize that application. They can't tell them, oh, actually, if you've gone for 5 megawatts less, the constraints in the grid wouldn't have been triggered, so you don't need that extra reinforcement. They'll just give them the as-is price on it. So the developers are stuck in this loop of back and forth, trying to figure out what's the optimum size asset for a particular location.
1 minute.
Our idea is basically grid connections as fast as possible. We accelerate that process by basically just doing our power flow analysis of the grid. Takes us about a second, allows them to focus their resources, get the quicker grid connection times, reduce their cost of capital. What are they paying for? Basically a menu of options. How much is it going to cost me to put in different levels of generation at a particular point? We identify the constraints, cost of the additional cost of the reinforcements, time to connect, and work at the NPV, so the developer gets a very, very quick range of options and stops this iterative back and forth process with the network operators. It's an incredibly popular product. It, basically shortens the timelines to get things connected, and yeah, it's great. Thanks. That's 5 minutes.
Thank you. Yeah, right on time. Well, I'm sorry that I had to rush everybody, but I wanted to make sure that all the startups had their 5 minutes to pitch. I'm glad we made it like right on time. So that means that we don't really have time for questions. There are a couple of questions here on the chat, so I will invite you to spend a minute or so to write some answer if you want to. Also, if you want to connect with each other, and if you did not catch the email, I'll be happy to provide make the connection and provide emails if you want to. Then I want everybody to take a second to upload their work today, because I think it was pretty intense, and you all did a really great job, and the presentation were very interested. So thank you very much. Mark, is there something else we want to add before we close on the call?
No, I really appreciate all of the pitch sessions and the panelists. That was there's a
Yeah.
lot of information that came out in those 2 hours. So we'll have to sit back and absorb it. So thanks for joining
Yeah.
us.
And if we can have some feedback, we would really appreciate it, because we're gonna try to have more events like this maybe. And so please reach out to me and give me some feedback so we can improve. Dean, did you have a question? I don't know, you raised your hand.
I didn't. Sorry, Annelies. I
Okay.
accidentally pressed the hand raise.
A hand instead of uploading maybe. Okay.
Yeah.
Okay. Thank you. Yeah. Thank you very
Thanks a
much.
lot.
Cheers,
Yeah,
everyone.
for me.
Bye-bye.
Thanks, everybody.
Have a great day. Bye
You
bye.
too. Bye.